This week, you're going to be solving problems using acute triangles with both the sine law and the cosine law. So you're going to need to distinguish when you use which law. As a reminder, you can use the sine law when you have any two sides in the triangle and an angle opposite one of those known sides. Or you can use sine law when you have two angles in a triangle and any side. The cosine law, on the other hand, you need to have two sides and a contained angle, or the angle in between two sides, or you need to have all three sides when solving for an angle. So if we look at this first problem, can you determine the unknown angle? And if so, would you use the sine law or the cosine law? And then we're going to determine the unknown angle. So if we look at this first problem, we have two known sides and we have an angle opposite one of the known sides. Okay, that angle is not contained in between the two sides, so we wouldn't be able to use the cosine law here. And we don't have all three sides of the triangle, so we wouldn't be able to use the cosine law either. So if we look at this, just to reiterate, we have two sides and an angle across from one of those sides, which is the situation we have here with the sine law. So if you look, we're looking for an unknown angle using the sine law. So if we set this up, we have the angle, which is our unknown. So we'll start with that, sine of the angle divided by its side opposite, which is 3.1 centimeters. And then since we started with the angle on the first ratio, we will do that with the second ratio as well. So we're going to start with sine 60. And that's across from the side 2.7. Now, if you remember, what we want to do is isolate this angle, so we're going to multiply both sides by this 3.1. And what this is going to do is isolate this sine of the angle theta, and we're going to type this in the calculator. Sine 60 divide 2.7 multiplied by 3.1. And if we do that, we get 0.9943. And then lastly, to find the angle, we need to do the inverse sine. So we're going to do the inverse sine of 0.9943. And when we do that, we'll get the angle is 83.89. Now it doesn't specify to round this to the nearest degree, so we'll leave 2 decimal places. And this is our solution. Now, if we look at B, B has three sides and one unknown angle that we're looking for. Now, again, as a reminder, with the sine law, we need two sides and an angle across from one of those sides. We actually don't have any angles in this triangle, so in the other option for sine law is to have two angles and any side. So to use the sine law, we have to know at least one angle in the triangle. And if we don't, we cannot use sine law. So we are forced to use the cosine law here. This option, all three sides, knowing all three sides, we can solve for any angle in the triangle using the cosine law. So if we use the formula for cosine law that's rearranged for finding angles, the cosine of this angle is our A side squared plus our B side squared. And if you remember, the C side has to be across from the angle we're looking for. So in this situation, I'll write this formula up here. Cosine, as a reminder, it's A squared plus B squared minus C squared divided by 2AB. So if I fill this information in, I've called the A side 10, and I've called the B side 18.8. If these are switched, it's okay. And we're going to subtract 19.7 squared. And this is going to be divided by 2 multiplied by the A side again, multiplied by the B side. Now if we calculate what's in the numerator, so 10 squared plus 18 squared, subtract 19.7 squared, you should get 65.35. And if you multiply 2 times 10 times 18.8 in the denominator, you should get 376. Now when you divide these, you should get a decimal number. So 0.1736 if we round this. So to do the inverse cosine to solve for the angle, and then we'd find our angle is 79.99 degrees.